Hi guys, right, we've got a slightly different one here today. Before we go any further, if you have one of these that's in service and want to pull it apart, then you need to stop and listen to what I'm going to tell you. This device can kill you. No ifs, no buts, no nicey bits around it. If you screw up with this, this can kill you. This one has been powered down for quite some time, is unlikely to be a problem, but it's always worth checking. If you are pulling one of these apart, for the sake of seeing how it goes back together, you absolutely cannot use this on a patient until you've had it calibrated and tested. Unless you know what you are doing, pulling one of these apart, you run the risk of creating a device that will fail to shock when it's needed. Do not take one of these apart for a laugh or out of curiosity to put it back together and use it again. This machine will never ever be used again. It is an older model. It doesn't necessarily comply with resuscitation guidelines, and it has been powered down for some time. I know how to service and work with defibrillators safely, so I'm not at much of a risk. Never say that you are at no risk. As I said, there are no old, bold electricians. Anyway, got that out of the way, let's have a look at this. So this is a semi-automatic defibrillator. What this means is you put the pads on your patient, the machine will listen to their heart rhythm via the pads, and then it will give you instructions and feedback on what you need to do to keep the patient going. I don't know that this model specifically does give guidance on how to perform CPR. That's one of the reasons why it may no longer be to code. However, the newer ones do give you very detailed information on what you need to do. After a period of monitoring, the unit will tell you to stand back. It will analyse the patient again, and then it will tell you if you need to press the shock button. And this is the reason for the semi-automatic, because you still have to press the button. The machine records everything that happens on a CF card, which is in this slot here. For some reason is made deliberately slightly unstandard. I think this actually is a PCMCA one in this one. And then you've got limited instructions there as well. These have to be tested, they have to be checked to make sure they're safe, because again, this is quite capable of killing someone if something goes wrong. So we're going to tear into this, have a look. We'll have a quick look at the front panel on here. So there's not a lot to go on. Your pads go in here, you turn it on, it will give you guidance, you press the button. You've got a contrast control, and you've got this interesting little device here. So the red X that you can see now means that this is not in service, and obviously having a permanently lit indicator draws a lot of power. These things are designed to stay on standby for years. So what they have here is a simple liquid crystal display, and when the display is energized, which uses next to no power, it blacks out that cross, so you just get a black display in there when the machine is good. I'm not going to power it up to show you doing that. I'm not going to show you it in operation. I will go and grab one of my personal machines and just show you quickly how it powers up and how it works. But I don't want this powered up because I don't want to have to deal with the defib cap inside it. So let's flip it over and find out how we get into it. So I can see we've got rubber plugged screws here. Let's pop those out. They will almost certainly not be standard screws. They're not, they're Torx. So let's just get all of these plugs out. These are designed to be fairly easy to service. They should be regularly serviced. As you can see, this one does have test certificates in there. Test certificate, test sticker on it. And I think this is all... oh no, there's some more in there. There are a lot of screws in them. They're designed to take a bit of a beating as well. This case is absolutely solid. There's no shortage of rubber. I mean, I don't know if that comes through on the microphone, but there is no give in any of this. And to be fair, some of the abuses get put through. They need to be that way. I believe they are fairly watertight as well. Right, I'm just going to pause you while I grab the right screwdriver. Right, we're going to go with the impact for this just in the name of speed. I think that's probably our lot. There won't be any hidden on here. Again, these do need to be serviced, they do need to be maintained, so hiding screws is not really going to benefit anyone. Get these out. Incidentally, if you don't know how to use one of these, there's not really, how do I put it? There's not really a massive amount of skill involved in using a automatic defibrillator. As long as you can follow instructions, you'll get on just fine. And these things do save lives. If you don't know how to use one, or you want to know how to use one, there are a number of private medical providers that offer courses, and obviously St John's, Red Cross and various other charities do as well. They are ubiquitous now, they are everywhere. For example, my own car and both our trucks have defibrillators on board, and my partner's car also carries a defibrillator, and everyone involved knows how to use them. These really can make the difference between life and death. So let's just, we don't quite pop open, which implies that something has been missed. That one is definitely out. There we go, we're up. So again, I don't want to put my hands in here without knowing what I'm touching, so I'm quite deliberately not just randomly sticking fingers in holes. What we've got is a glued seal on the end here. That's what's held us up. Pull that seal off. Right, as far as I'm concerned now, the life of this defibrillator is over. There is nothing more that this can be used for. It's not safe, and I wouldn't put it back in service even if it did comply. Now we've got, I believe, a large potted module in here. So I'm not sure how much further down we're going to get on this. Right, bear with me. Right, so the first thing I need to do is make sure that this is safe to even go near. So we'll turn the meter on. We want to be on volts. I'm not expecting anything. So we've got something in here. We're not sure what. However, we've got a lot of heavy duty current sensing. We've got our switching here. These are probably IGBTs. So it's a fairly good bet that these two terminals here are going to be the capacitor. Okay, we've also got another one here which potentially has load sensing on. We'll check that. There's nothing there that I'm worried about. And we will check across these inductors. Right, so we're fairly safe there. Okay, so we're going to have to tear this down to really get into it, so to speak. We can't get this off without getting the board out. So let's have a quick look at what we've got here. As you can see, there is an awful lot of very high power electronics on here. The design of these varies between manufacturer. This is a, which one this is? This is a Heartstream, also known by a number of different names. And we'll just have a quick look at what we've got in here. So this here is the back of our LCD, and we've got a microphone here. These literally do record everything that's going on, so it can be analysed later. And you'll see that there is a lot in terms of compliant padding in here. Everything that is likely to wiggle around has got a pad on it. We'll pop that off. So we've got a large amount of analog to digital conversion here. So we've got an ADG 513, AD 7872, and ADG 4063, I believe. So this has to do several things. So as well as charging itself, monitoring, and generally making sure that it is behaving in a safe way, ideally it needs to know exactly what's happening with the patient as well. So there is an ECG machine built into this as well, which is how it works. What we do is we monitor through the pads. There will be an isolation transformer for the ECG underneath here, I believe. I'm pretty sure we're looking at the input there. Let's just pull those off. I have brought my defib in as well. So we will just pull these off. He says everything in here will be super safe, super redundant as the end of that comes off. And we've got more there. So I think we've possibly got the transformer and the pad output here. So what I want to do now, just in case, is we're going to pop that NAJD cable in there. I don't know that we've got the same option on these, so I'm just going to cut these. Obviously, if this machine were going to be going back in service and this were a service or a repair, this isn't really quite the way you'd go about doing this. But this is more me making sure that things aren't just going to give me a nasty surprise. Right, we'll just go this route rather than trying to preserve them. As you can see, these are silicon wires as well. Again, flexibility, durability. These are not quite as built down to a cost as most electronics are. Right, there we go. That's those out of the way. So we have a screen here, and we have, are they inductors or resistors? They're resistors. So these two tabs here are going to be your output to your pads, and then we have under there more loads and an isolation amplifier, and then you're into your ECG monitoring here. So that'll be what this is about. We'll have a look at some of these chip names and see what they are. I'll put them up on data sheets. But as I say, there's a lot in here. That it's not just a big transformer and a set of pads. Looking around, we have our power section here. So we will be switching a transformer somewhere. I don't see the transformer. I'm guessing it's in there. And then there are requirements as to impedance matching and shaping the actual pulse waveform. That's why we've got our inductors here, and we've got relays to switch these in and out and to do discharging as well. These are either IGBTs or SCRs. They are SCRs. As you can see, there are a lot of them. They use a lot of current, and it's that's used to do the work. And obviously this gives you an idea of just how much current is being dumped through those pads. The duration of the shock is incredibly short, and the waveform that's used is incredibly precise. It isn't just a big jolt now, it is what's called a biphasic waveform, which means the polarity on the electrodes will switch as the shock is delivered. Coming down here, we've got power supply goodness by the looks, and we've got an isolated power supply here. That's a proper isolation transformer, and we've got our micro here, which is an Heartstream Q-Chip 2. That is going to be custom silicon. That will not be off the shelf, and it will be available only to them. There will be no information on it, and Lord knows what it actually does. We have some current sensing on whatever this leg is here. We'll go to take that off in a minute. But we are definitely sensing current on that. I think that one may actually be the transformer. So let's just get those out. And I've just noticed my bodged wire link over there is gone, so I'm going to short that again. So when I'm actually working on these, I've never done one of these before. When I'm working on these, I actually have a selection of cables that will keep the capacitor shorted out. So we need to take our little conformal block off of here. There you go, you can see those SCRs, and for those playing along at homes, they are IRGPH50F, and that is an IXG HZ2N102. They're marked as Qs, so I think we've got possibly IGPs and SCRs in. That's the same. That's the same. Yeah, so we've got a mix of, that's an IXIS CS9128, IXIS CH9128, and again, and these are actually transistors. So I will pop these up after I edit so we know what they are. Our board is loose. We should be able to just lift this out and pop the ribbon off. So we've got what looks like, I'd say it's a 40 way, but it's a 50 way, so it's an incredibly small 50 way. And I think I'm going to have to stop in a minute because it looks like my battery is getting low, but we'll go until I can't. We've got some normal screws now. I think that's just to hold the display in, and we can see down, looking down there, that is a PCMCIA card, so that will be a PCMCIA memory card. I suspect the recording functions and everything are kept separate on this board. Can we get this out? Yes, we can. Feels like it's another screw somewhere, but I'm sure there isn't. Oh yes, there is. There we go. Is that it? Right, okay, this is the processor. Didn't realise this board was down here. I did wonder how this was getting along with as little as it was. So we have two Oki display drivers, I believe. We have a custom ASIC there with its memory. We have a 68HC16. I believe that might be a cold fire processor, so we're not short on processor speed here. We have some more memory and we have some flash. Right, back again. I had to put the battery on charge. So we've got a display cable here which we need to take out of the way. Let's just square up a bit. We'll look at that board in a bit more detail in a minute. So we'll just pop that out. We have another board underneath which is probably LCD. We've got some more cables here. Let's just pull those out. I still don't quite necessarily understand how we're going to get to our transformer and cap. There are definitely some screws in here. We'll have a good look at these boards afterwards. So this is all badged as Heartstream, and we've got a date there of 1996 for the design. Can I see a date code on anything? It's not going to be 64, I know that much. 06 possibly. 06, 06, 07, 07. So yeah, we're potentially looking. Was there anything actually on the back? Medical stuff quite frequently does have manufacturing dates on. No, but I've just seen that serial number. That is an incredibly low serial number. 4,255. I don't know that there's another service date under there either. There may be a date behind there somewhere. Right, so this board should now be free to come out. So this is obviously our digital and all our processing. We've got a, that looks like illumination of some kind, and we've got our big buttons on the back, they are just fairly standard tactile domes. Lots of LEDs around that one to make it illuminate. I thought there were only... Right, this might be for another model, but we've got a button here which has no corresponding button on the front, but there is definitely a space for it. So this board used in another module may allow for a manual defib mode. So we'll have a look at that in a bit more detail. We have, what is this? This looks like just a shield. Yep. And this is going to be a fairly standard off the shelf Hitachi. There you go, it is actually a Hitachi LMG 713PNFL. So that's going to be an off the shelf graphics panel. It won't be text, that will be graphics. So we're down to this level now. Now, is there any way we can get in any further? There must be, but I'm not overly sure how. We've got something there. Let's get the knife of doom and prise that up. Can we prise that up? Nope, I don't think that's going to do anything for us. Okay. I'm not sure what this extra area down here is. So there must be a way in. There's the elastomer strip for the little LCD. And that's tucked in there in such a way that suggests that was in fairly early. I don't know if you can see that, but we have two screw holes here. This is quite clearly one part, this LCD module, and then we've got this over the top, so I'm not actually overly sure how that would have been installed. It can't slide out this way because it's wedge shaped. There must be a way to get to that. So we now need to see if there is a way in here. I reckon it's got to be these end caps somehow. It doesn't feel like it. There must be a way in. Bear with me, let's just deploy unreasonable violence. So we have deployed the AVE high resolution imaging system, and as you can see, it's worked an absolute treat. This is going to take forever to clean up. So this is completely sealed. It's not potted, but it's completely sealed. So let's have a look and see what we've got. So first things first, we need to get these wires out. So we don't have a coil in here, we just have the cap. So the high voltage generation is going on somewhere else. So why do we need 4 wires for this? I'm guessing there must be a sense type arrangement going on here. There are only 2 pins, so yeah, I assume there's a sense type arrangement going on, and this is our little LED. So that wasn't very exciting. And then in here we have the cap. I wonder if we can get this out. All sorts of reasons why this is a bad idea, but that's never stopped us before. It is a sticky thing that's holding this in. It does appear to only be on one end. Oh, just knocked you, sorry. I realise this is exactly not how to do this. And there we have our defib cap, which I noticed is no longer shorted. Let's just do that. Just bare these wires, and then we'll twist those together. Leaving large capacitors with the terminals open is generally considered to be quite a bad idea. So we haven't worked out how they got that LCD in there yet. I honestly have no idea how that would have been done. There is the microphone in there as well. So what have we got here? This is going to have a rating on it, one would hope. That is 1,000 microfarads, 2,200 volts, so 2.2 kilovolts rated cap. So that's going to be quite destructive. I'll have to see if we can do something with that. I've got neon sign transformers. We've got the SCRs and things over there, so we might be able to do something interesting with that. There is just defib chaff everywhere. So let's go back and have a look at this board. I know we gave it a quick look at, we can see what's going on a bit more. So all of this is going to be pulse shaping. I'm curious as to where we're deriving our high voltage from. There's certainly nothing on the board. So we've obviously got an analog board and a digital board. Those relays, those are high voltage inductors. That's way too small. That's a current transformer. We've got some strange hybrids up here, and we've got some isolation coils. So this is going to be all about sensing the ECG coming back from the pads and shaping and delivering the defib pulse. But I can't help feel that I'm missing something. Actually, you know what? There's the transformer there. Zoom you down. That multi-comp device there is our transformer. The reason I know that is we've got a high voltage glass style diode in there, and we've got anti-tracking with an actual physical barrier in there as well. So that's our high voltage source for charging the transformer, and that looks like that is controlled by that relay. So they're going to be fairly high voltage relays as well, I'd have thought. Nope, fairly standard. We have, so that diode feeds out directly to the cap, I'm guessing. Yeah, you've actually got the location for the wire there. So that red and white, that's the cap. So it's possible, because these aren't actually coils looking at them, they're resistors. So we've got 10 ohm, 10 ohm and 10 ohm. So there is obviously a discharge type arrangement here as well to keep this safe. We've got power supply stuff down here. That's a fairly hefty track, but I can't see quite where it goes. So we could be doing this in two stages looking at this. We could be stepping up to an intermediate voltage and then stepping up again to our higher voltage for our charging. So yeah, that's that. So we now know where everything is, and let's just have a quick closer look at the digital board. So again, we've got an ASIC here. We've got these two Oki chips. Now I think these two, I thought these two Oki chips might be graphics drivers, but I don't think they are. M6388, we've got two of them. Data acquisition type things maybe. We've got flash, our RAM and our 68HC16 processor. I'm pretty sure that's cold fire. And then obviously our PCMCIA slot for our RAM and our jumper, 50-way jumper cable up to the power board, and that's about all there is to it. So what should happen with one of these, oh, I'll get mine out. So this is a more recent version of the same unit. Let me zoom you out and zoom out a bit more. Because of the constant current, low level current draw that these have, we tend to pop the battery out of this. So we've got our pads here. So what you would do is plug your pads in. They go in there. Oh, need to chuck our battery in on this one. There we go. You can see we wake up. We'll turn it off. And there we go. So
apply pads to patient's bare chest. Plug in pads connector next to flashing light.
So there you go. Your pads go on the patient, and then it would start monitoring.
Apply pads. Plug in connector.
It won't shut up until you do it and turn it off. Curiously enough, the reason I've got this one is this one had stopped talking. I'm trained to do this with or without an AED, so
apply pads.
It wasn't a problem.
Plug in connector.
But as you can see here, this one is flashing there over that little LCD icon, and you can see this is very similar layout to the other one.
Apply pads.
You'll see
insert connector firmly.
It really doesn't give up. I'll turn it off. You can see it says low battery there as well. In terms of actually using them, they are very, very simple. They're designed to be simple so that anyone can use them. I've got new pads and things to go in this one, which you need to go in here. And you'll hear now that we have a beep. This is to signify that the battery is low. You'll see that the warning is still flashing. This will generally sit in the back of the car and drive me insane, hence the reason we don't keep the battery in. Got it? Yep. So there you go. There's one that we've basically turned into plastic dust, and a working one for you. Everyone should know how to use one of these, as I've said already. There are plenty of training courses around. There are plenty of organisations that will train you on how to use them. And I really strongly recommend that if you are offered the opportunity, you do take it. You could save a life. I know everyone says that. It's one of these cliches that's often trotted out, but no, really, if you can actually use one of these, there is a very real chance you could save someone's life. So please learn how to use it. Anyway, I need to sort all of this lot out now and tidy up. So, oh, by the way, there was a speaker in there as well. Anyway, take care. Catch you soon.